In today's lesson, we are now going to focus on finding the equation of a quadratic function in vertex form. So we're going to continue on with this vertex form. Vertex form, a reminder, has three parameters. A, which is our vertical reflection, vertical expansion, vertical compression, right? The shape of the parabola and the direction of it opening. The P is the horizontal translation parameter. Right, so if that was -1, it goes right 1. If it was +1, it goes left 1. And Q is our vertical translation. Okay, so if it was +8, it goes up 8. If it was -8, it goes down 8. Those are the three things we need in order to find the equation of a quadratic function. Now, the P and the Q, a reminder, come from the translation to the vertex. So that part is where we would start. Okay? The 3 and the 2 in this question describes that this parabola from my origin has gone right 3 and down 2. So my P is 3 and my Q is -2. So I would always start by plugging that in. So I have y equals a, and since it's 3, it's x minus P, so x minus 3, that means right 3, don't forget your little squared, and then -2. Okay, so we have everything put in except we don't know A. A describes the shape. Well, first off, I know it opens up, so I know A is positive. Second, I know that when A is 1, it follows the shape of over 1 up 1, over 2 up 4, over 3 up 9. So if it follows that pattern, we can just substitute 1 for A. If it goes over 1 up twice 1, over 2 up twice 4, then we know A is 2, and we can just substitute 2 in for A. The other way we could do this is we could do it algebraically. So if that pattern wasn't followed, in which this case I know it's 1, but we're going to show you how you can find this algebraically as well if you can't see that or you don't have the graph provided. I can just take any point on the graph, right, because these are all xy pairs that work inside my rule, right? They balance my equation out. So I can plug in 5 for x and 2 for y, and I can algebraically find A, right? I'm going to get 2 equals 5 minus 3 is 2, 2 squared is 4. Instead of writing A times 4, I'm going to just switch the order. And then I'm going to add 2 to both sides. So I'm going to take this -2 to the other side. It becomes +2. And now I'm going to divide both sides by 4, right? And I get 1 equals A. Oh yeah, A is 1. That is the shape of the parabola. So now I substitute 1 in for A, which you don't need to write when it's 1. And so now I know the equation of this parabola is this. All right, let's try a couple more. In this case, I can see that my P is 4 and my Q is 5. Okay, so that's P, that's Q. Got that part. Do I know A? Well, I know A is negative, right? And I know it opens down. Sorry, it's negative because it opens down. And I know that when instead of going over 1 down 1, I'm going down 2. Instead of going over 2 down 4, I'm going down 4 twice. So I now know that A is -2, right? It's growing twice as fast. I could do all the algebra again, but since I don't need to, I can just substitute everything in. Y is -2, x minus 4, don't forget the squared, and then plus 5. A lot of people forget that squared, right? It's where the quadratic comes from. All right, in this one, I know that P is -5 and Q is 2. All right, but I'm not quite sure the shape here. So I'm going to use my algebra here. I'm going to borrow this xy pair. So I start off with my P and Q. So I get y equals A, x minus -5, which becomes +5, all squared, plus 2. And now I'm going to substitute these values in place of y and x, right? Because there's infinite yx pairs that balance this, and all these yx pairs are on this parabola. Okay, and I'm just going to borrow one of them to find the missing part of the rule. So I'm going to plug in 6, I'm going to plug in -1, And then I'm going to solve this equation, right? So in the brackets, I get 4 squared, which is 16. I'm going to subtract 2 from both sides. Now I'm going to divide both sides by 16. And now I'm going to reduce that fraction to lowest term. So I now know A is 1/4. It's positive because it opens up, which is good. I did get a positive. And it looks vertically compressed, so that answer looks reasonable. So I'm going to put in y equals 1/4 x plus 5 squared plus 2. This is the equation of my parabola in vertex form. All right, if I wanted you to determine the y-intercepts of these, right, you can see by just looking at the graph here, I'm not sure what the y-intercept is. I don't see it. But now that I know the function, right, I know the y-intercept is the value of y when x is 0. So I just have to put 0 in place of x. So up here, I would say, okay, to find the y-intercept, I would just plug in 0 for x. And then I would just do my order of operations. I would take my -4 and square it and get 16, right? And then I'd multiply my 16 by -2, get -32 for all of that, and then add 5. And now I know that y is -27. So way down at -27, right, on my graph at -27, that's where I know it's finally crossing, all right? So make sure you understand how to find the y-intercept. You plug in 0 for x and find y. You just evaluate it. But I didn't know this without being able to first get the function. So you first find the function, and then you can evaluate it. Okay? And then we could do the same over here. I could put in 0 for x. So I would get 5 squared, right? Because 0 plus 5. So in this one, I would go 25. Divided by 4, which is 1/4 of 25, and then I would add 2, and I would see that my y-intercept is 8.25. Couldn't tell there, right? By looking at it, you don't really get accuracy, but now that I have the equation, I know it's exactly 8.25. All right. Sometimes I don't give you the graph, I just give you the information. I give you the vertex and 1 point. Well, it's the same thing. You know the vertex is P and Q, and you know this is a point that balances the equation, satisfies the equation, so you do all of the exact same work, okay? If you want to pause the video and try it, go ahead. I'll show the solution now, and you can unpause when you're ready and check your solution. So I'm going to now just leave A, I don't know it. I don't even know if it opens up or down right now. I guess I could graph it and look at that, but I'm just going to substitute in P, again, plus 3 squared and plus 7. And this is a point that works, so -5 is going in place of y. -1 is going in place of x. Right, now I'm going to get -5 equals, this becomes 2 squared, which is 4. Subtract 7. Divide by 4. And there you go. We now know y is -3. X plus 3 squared plus 7, right? So I had almost it all there, but I needed this to find A, right? Once you know A, you substitute it in, and you have the entire equation. Now I can answer different things. Oh, yes, it's been vertically extended factor 3. It's opening down. The vertex is -3, 7. I already knew that. The axis of symmetry is x equals -3. The range, since it opens down, is y is less than or equal to 7. Vertex form gives you so much different information. Right? The vertex is -4, -12, and the y-intercept is 1. Remember, when I give you the y-intercept, I'm really giving you a point. I'm giving you the value of y when x is 0. So again, it's all of the same as above. You would then first start with the vertex. Don't know A. X plus 4 squared minus 12. I would substitute this in place of y and x. X is 0. I would get 1 equals 16a minus 12. Add 12 to both sides. Divide both sides by 16. And this is the value of a. I could leave it as this, as a fraction in lowest terms. I could change it to a decimal. It doesn't matter. I'm just going to leave it as a fraction, as 13 over 16. X plus 4 squared minus 12. There's your quadratic function given these properties. We could sketch a quadratic given some information, making sure we really understand the symmetry part, okay? Based on the range, the axis of symmetry, we can now figure out other pieces of our parabola based on this. So in this question, we have a quadratic function. Its x-intercepts are -1 and 3. So I know it's going through those two different points. And its range is y is greater than or equal to -8. So 1, 2, 3, 4, 5, 6, 7, 8. There's -8 down there. So I know the vertex falls somewhere along there, but I'm not quite sure where. Well, if it goes through these 2 points, remember 2 points that line up horizontally from each other are equal distance from the axes of symmetry. So if the total distance between these 2 points in a horizontal way is 4, the halfway is 2. So I now know where my axis of symmetry falls. And don't forget, the axis of symmetry also goes through our vertex. So I now know where our vertex falls. Our vertex is at 1, -8. And it goes up through there, and it goes up through there. Okay. So now I have the vertex, and I have 2 points. I can now find the equation of a line. Okay. So let's just check. If I go over 2, I'm going up 1, 2, 3, 4, 5, 6, 7, 8. Oh, if I go over 2, I'm going up twice what I should be. So I don't even have to do the algebra. I know A is 2. It opens up. So only use the algebra if you don't know the shape. If it's not the 1 1s, 2 4s, 3 9s, or a multiple of those y's, the height values, then you'd have to use the algebra. So I'm going to get y equals 2 x minus 1 squared minus 8, right? Write 1, down 8. That's where the vertex is. Don't pass that.